Okay, hello everybody. This is my first question for mathematical tricks. We have this question, that is, find two natural numbers x and y such that x plus twice of xy plus y is equal to 10. So what we are asked here is we need to find any two natural numbers x and y satisfying this condition, that is, the sum of the first natural number plus twice of the product of the two plus the second gives this one, that is 10. So in order to find these two natural numbers, the only suitable method that should be applied will be factorization. That means factorizing this trinomial as a product of two binomials, so that even though we are not able to obtain two specific binomials whose product is exactly equal with that of this one, but we can find two binomials whose product is differ from this one by at least a constant. So that in order to make factorization simple, let us multiply both sides of this equation by 2. So that we will obtain this one, that is twice of x plus 2 times 2xy, which is twice of 4 times xy, plus twice of y is equal to 2 times 10, which is 20. Now we have this trinomial. First one is 2x with the coefficient 1. We have 2y with coefficient 1 and 4xy. So that let us try to assume or simply think that a product of these two binomials which gives or which may differ from this one by at least a constant, a certain constant. You know that here we have 2x and the coefficient of this one is 1, so that let's add 1 here, that is the first binomial be 2x plus 1. Similarly, for second variable, that's simply 2y. We have 2y here, so its coefficient is 1, that is this one, let it be 1. But the product of these two could be 2x times 2y will be 4 times xy plus 2x times y, which is twice of x, 1 times y, 2x times this one for xy, 2x times 1, that is 2x, or 1 times 2y, which is plus twice of y, plus 1 times 1, that is 1. So when we compare the product of these two binomial, that's simply this one with this trinomial, we have, for example, 4xy here, we have 4xy, we have 2x here, we have 2x here, we have 2s, y is also here. But there is a constant that's simply 1, which is absent here. Therefore, this product of these two binomial, that simply this term will be, or this expression will be obtained from this one by adding this constant that's simply 1 from here. So that in order to equate or simply balance this equation, this constant must be added to this side, to the right side of the original equation. So that we have twice of x plus 1 multiplied by twice of y plus 1 is equal to 1 times 20, that is 21. But we know that the factorized form of this one, that's simply 21, is equal to, it is 3 times 7, or they had equated with 7 times 3. And we know that because we are searching, that is these two natural numbers x and y, we have this binomial, that's 2x plus 1 must be greater than that of 1, even this must be larger than that of 1. Therefore, from the first one, that's simply here, let, for example, the product of these two, that is 2x plus 1 times twice of y plus 1 is equal to the first factorized form of this one, that is 3 times 7. So that from this we have either 2x plus 1 is equal to 7, 3, and twice of y plus 1 is equal to 7. So that from this what we have the value for x, that is twice of x is equal to 2, which implies x is equal to 1. And from this equation again, we have twice of y is equal to 7 minus 1, that is 6. So that we have y is equal to 6 over 2, that is 3. Therefore, the first possible value of x and y satisfying this condition will be that is xy, which is equal to 1 with 3. Similarly, if we change the factorial form of this one, that is 3 and 7, which with 7 times 3, we have twice of x plus 1 is equal to 7, and twice of y plus 1 is equal to 3. So that from this, it's already obtained or simply satisfied from there. We have this one, that is x is equal to 3 and y is equal to 1. Therefore, the other possible value of x and y could be the set or the order pairing, that is 3, 1. Therefore, the solution set will be either 1 with 3 or 3 with 1. Both these two pair of natural numbers can satisfy the given equation. Okay, this is what the solution looks like. If you like this video, don't forget to subscribe the channel.